Let's get to second term. So second term, interesting term, important term is CD20. CD20. And why this is crucial? It's crucial because it defines the B lymphocyte. Okay, so B lymphocyte or B lineage. So it defines B lymphocyte. And another thing which is important is that there's a drug that works against this. It's a monoclonal antibody and it's called rituximab. Okay. What is crucial over here is that some cells don't display CD20, and that is the reason why WHO classification doesn't put Hodgkin's lymphoma under the B lymphocytes. Although we know it's through sequencing, we know it's a B lymphocyte, but it's not expressed in CD20 or very lightly, very, very much lightly. Okay, so 3, CD30, that's the one that is expressed in Hodgkin's lymphoma, and CD20 is not. But against CD30, we got brentuximab, another drug. Okay, so that's rituximab and brentuximab. Those are monoclonal antibodies aiming on CD20 and CD30. So some comments to this. Then another comment, 4. What are the neoplasms from the plasmacytes? So plasma cell neoplasms that are not lymphomas. And you know it's multiple myeloma. Okay. And the reason is it's not expressed in CD20. Okay. And also causes no lymph adenopathy. Okay. So there's no lymphadenopathy and it's not expressed in CD20. Okay. That's important. In contrast to this, a plasma neoplasm that is considered as, so plasma cell neoplasm that is considered as lymphoma, that's another one. That's Waldenström Macroglobulinemia. And this one expresses CD20. Okay, so that's why you take it as a lymphoma, and it causes lymphadenopathy. Okay. And we're going to come to this later. So still with the plasma cell neoplasms, you can still put there MGUS, which is a, let's say, a phase before multiple myeloma develops. MGUS is, I mean, the only thing you find is an increased monoclonal antibodies in the blood on electrophoresis, but that's it. And still another point over here is 5. What? Lymphoproliferations cause bone lesions. Okay. And remember, it's of course multiple myeloma again, but not only that, it's also ATLL, and watch out. So this one is connected with the HTLV virus 1, and there's a special thing for the international tests. And remember, multiple myeloma is not invading skin. So you won't have a rash, you won't have problems with skin, but with ATL, you will have a rash. It's a T lymphoma and invades skin. So typically, if someone asks you if there is some rash on the skin plus bone lesions, it's rather ATLL, okay? Not multiple myeloma. It shouldn't have a rash, okay? In contrast to these two, Waldenström Macroglobulinemia. There are many plasmacytes, but not as much as in multiple myeloma. They say 5 to 15% that are in the bone marrow. There are no bone lesions, okay? No bone lesions. So bone lesions are only in multiple myeloma or ATLL, not Waldenström Macroglobulinemia, although it's a plasmacyte malignancy. Okay? So that's about these differences. And I think I'm going to skip the Ann Arbor classification over here because it's more like clinical stuff. But still, with the pathophysiology, what is important over here? 6, you should know what is a Cyclin D1 and to what it is connected. So we're going to talk about it later, but this is the Cyclin D1. What does it do? It starts a mitosis, so it switches the cell from G1 to S phase. It activates the cyclin-dependent kinases. Okay, so activates cyclin-dependent kinases. And if you have too much of it, as that is when you have a translocation of 11 to 14, you're going to have Mantle Cell Lymphoma. Okay, so it's a proto-oncogene. If there's too much of bcl-2 in the cell, this is an anti-apoptotic protein. And normally in cells you don't want that, but in lymphocytes you want that during the affinity maturation. So if the lymphocytes are reacting too much towards your own tissues, causing autoimmunity, or they are weak in response to other antigens, you want them to go under apoptosis. Unfortunately, if you have too much of bcl-2, they won't go under apoptosis and they will survive and they will cause a follicular lymphoma. That's typical mutation. We're going to talk about the translocations later. And last one out of these mutations I would like you to remember is a C-MYC. And this is, of course, transcription factor that again drives the cell from G1 to S phase and increases the DNA synthesis and makes cell to divide. And this is typical mutation. It's a very strong mutation that causes cells multiply very fast. And that's typical for Burkitt lymphoma. So with these mutations, you should remember Cyclin D1, bcl-2, and C-MYC. Okay. So those were some terms, and let's get to node architecture. So, thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.